So, good morning, friends. Welcome to Water Resources Engineering class. Today, we start the Unit 4. Unit 4 consists of two aspects. One is groundwater, hydrology, and second one is water requirements of crops. And today's focus in that groundwater hydrology is types of aquifers and the properties of aquifers and aquifer constants. These are some of the items which we will discuss in today's class. How to classify aquifers? How we can classify aquifers? What I told aquifer means aquifer is a geological formation that can store water and that can transmit water in significant quantity. That means this is the water which can be used. This is the used groundwater actually, right? And these aquifers can be classified broadly into 4. Out of these 4 also, this first one and second one is common thing. Third and fourth ones are only for definition sake we are giving it. What is an unconfined aquifer? An unconfined aquifer is what? A confined aquifer is what? These two are very, very important. The rest two are only for description purpose. Let us come to unconfined aquifer. Unconfined aquifer means that is the water available basically from the impervious surface to basically the ground surface, right? The upper surface for it is the water table, because above water table the water that is its unsaturated zone. So from the impervious surface up to the water table, whatever water is there, that you can extract. So an unconfined aquifer means there is no confinement. The top is what for unconfined aquifer? The water table is the top. Below the water table, whatever water is there up to the bottom of the thing, rock or bottom of the thing, whatever is there, that is what we call it as here. And once I say water table, the water table is always such that the pressure at the water table is always atmospheric pressure, and then easily recharged because it is the top layer. So that actually this unconfined aquifer can be easily recharged. Whenever the rainfall is there, that can be recharged. So right, so these are the 3 important things. We will study about it later. But what is unconfined? If you see here in the figure actually, so whatever water table is there, this is the impervious portion. From the impervious portion to this, in this zone, if you are taking water from outside, this is an unconfined aquifer. So in the unconfined aquifer, we have a well, and from this well we are taking water actually. So unconfined means from the impervious portion to the ground surface, and mainly the water is present where? In this zone only. So if you dig a well into it, you can extract water. And what is the pressure at the water table? Atmospheric pressure. What is a confined aquifer? The confined aquifer is an aquifer where the water is stored between 2 impervious regions. So this is one impervious portion, this is the other impervious portion. Between this first impervious portion and the second impervious portion, the whatever water that is stored, whatever water that is moving is what we call it as confined. The water is confined between 2 impermeable zones is what we call it as confined aquifer. So if you want to dig water, extract water, you need to dig well into the confined aquifer. So that means you have to break the rock and then push the well into it, tube into it, then only you can basically recharge. Whereas the recharging of confined aquifer will not occur at the place. So it occurs kilometers away from it. Suppose if you see, I have a well here, naturally here recharging thing will not go into the confined aquifer. Here whatever recharge occurs, it goes into the unconfined aquifer. But how water comes into the confined aquifer? It comes from somewhere very, very far kilometers away, there actually because of its position, because of its topography, how the layers are, from there it is recharged somewhere very far, and then naturally it flows, and at some other point we are extracting from it. So here we have shown two types of wells. One well is such that when the moment we dig into this impervious, this is the impervious zone, then naturally it is automatically flowing out. So this is what we call it as the flowing artesian well. Whereas here naturally it rises to some level above water table, and that is what we call it as just artesian well. So one is flowing artesian well, general ordinary artesian well. So but water is confined between two impervious zones. So from there you are pumping it. So this is the thing. Whereas the unconfined aquifer, recharging is very simple because at the same place. Whereas in the case of confined aquifer, the recharge has occurred from somewhere, so very far actually. And what is the perched aquifer? Perched aquifer means if you take an unconfined aquifer, the unconfined aquifer, what is the water level? Naturally, the water table is the main thing. So between the water table and the ground surface, if any in between, mostly that is if you take it an impervious zone. In that impervious zone, small sandy belt like thing is there. A small sandy formation is there, right? It is from water table to what you call it as the ground surface, it is impervious zone only. In the impervious zone, if suppose you find some small soil zones like, that's why if you formed a localized impermeable layer, so that means we found this is an impervious layer actually. So it stores some quantity of small water, and such type of water is what we call it as perched water actually, perched aquifer. And what is the leaky aquifer? The leaky aquifer is nothing but a semi-permeable confining layers allow slow leakage. For example, in the confined aquifer, the semi-permeable, because these two impermeable zones are not completely impermeable, semi-permeable confining layers allow slow leakage of water into or out of the aquifer. For example, if this is semi-pervious, it leakages water into the confining zone. Whereas it is basically a semi-pervious, it leaks out of it actually. So that is what the fourth. So what is the classification of aquifers? There are four classifications: unconfined aquifer, confined aquifer, perched aquifer, leaky aquifer. What is unconfined aquifer actually? From the impervious zone up to water table, whatever water is there, that can be extracted using the unconfined aquifer. That is real water that is available for us. That is the well water that is available for us generally, right? And it can be easily rechargeable. And the pressure at the water table is always atmospheric pressure. Whereas confined aquifer is only the water is confined between two impermeable layers. Naturally, the recharge is not straight away possible at the same place. Recharge will occur at some other place far away, kilometers away actually. If you want to tap the water from it, naturally you have to dig a tube well into the impermeable layer. Once you dig into a tube well into this impermeable layer, then naturally water starts flowing out of it. If water stops flowing just out of the well, it is what we call it as flowing well. Whereas if it is up to the piezometric surface, because always remember that in the case of unconfined aquifer, water table is the main, up to water table only the water is available. Whereas in the case of confined aquifer, up to piezometric surface, we don't call it as water table in the case of a confined aquifer. The terminology that we use in the case of basic confined aquifer is up to piezometric surface, because the pressure inside the confined aquifer is not atmospheric pressure. It is the water is confined between two layers. The pressure is greater than atmospheric pressure. So it is the piezometric surface, you should remember. What is the perched aquifer? In the zone between above the water table up to the ground surface, if there is a localized impermeable layer in which the water is stored, that is what we call it as perched aquifer. And leaky aquifer means in this confined aquifer, either the top or bottom impermeable layers are a little bit semi-permeable, then naturally water will be leaked out of the aquifer or water will be leaking into the aquifer. These are the four main types of aquifers. And this is the figure which you need to draw even in your exams actually, to show what are the various zones actually that will be there in case of confined or unconfined aquifers. So the same thing we have done it actually. So the characteristics of a confined and an unconfined aquifer, if you see it, in the case of an unconfined aquifer it is water table, whereas in the case of confined aquifer it is the piezometric surface actually. Whereas in the case of unconfined aquifer the water table fluctuates with season actually. Whereas in the case of confined aquifer, because the water is confined between two impermeable zones, naturally very small fluctuations. Whereas hydraulic gradient changes for rapidly in the case of an unconfined aquifer, but whereas that scope is not there, it's more or less uniform in the case of a confined aquifer. The recharge area is only just around the borehole, whereas here the recharge area is away from the borehole actually. So these are the basic different or characteristics of an unconfined aquifer and a confined aquifer. Let us go into the aquifer parameters, or we call it as aquifer properties. Anything is fine actually. So there are different properties or different parameters which we need to study in the case of an aquifer. What are they? First one is porosity, very important, porosity. What is porosity? It is nothing but the ratio of volume of voids or empty space or pores to the total volume of the soil actually. If you take it, porosity is defined as the ratio of volume of voids, volume of pores or volume of openings of the material to the total volume of the material. If you take it, this is what we call it as. So this is the empty space, the pore space, the void space inside the soil structure is what we call it as the porosity actually. So porosity is volume of voids divided by the total volume of the material, and it is V suffix V divided by total volume. For example, you take sand. What is the porosity of sand? So that means it varies from 25% to 50%. So that much empty space is there. Whereas clay, more space is there, 40 to 70%, high porosity actually. Whereas granite, almost no empty space at all, no pores at all, so 0%. So this is what generally you need to have an idea. But what it really signifies, definition is all right, but what porosity signifies? What do you mean by that porosity? Porosity is nothing but the water holding capacity of the soil is what is represented by porosity. The water holding capacity of a soil is what we call it as porosity. Porosity only tells us how much water it can store. It can store how much water it can store. That represents the porosity actually. A high porosity means, what do you mean by high porosity? Void spaces is more, number of voids are more, so that means more and more water it can hold. Low porosity means, what do you mean by that? The void space is very less, it cannot hold more water. So this is the high porosity, low porosity, that means it's all talking about what is the volume of voids compared to the total volume of the soil mass. That is what we call it as porosity. Then what is specific yield actually? The specific yield of an aquifer is defined as, it is the ratio expressed as the volume which after being saturated drained by gravity. The volume of water which you can drained by gravity, which you can transmit by gravity. The volume of water which you can transmit by gravity from a soil mass is what we call it as specific yield. How much it can transmit, how much it can hold is porosity. How much it can transmit is specific yield actually, right? It is volume of water drained, that means sending out by gravity to the total volume of the soil is what we call it as specific yield. Yield means output. Yield means something coming out. So that is what we call it as specific yield. So it is nothing but W suffix Y divided by total volume into 100. Whether it is porosity or whether it is specific yield, we always express it in terms of percentage, right? Specific yield, what it signifies, like porosity we mentioned, porosity means what it represents, the water holding capacity of a soil is what we call it as basically the porosity. Similarly, what specific yield express, water yielding capacity of a soil, how much water it can drain off is what we call it as the specific yield actually. Whereas what is specific retention? Specific retention means the volume of water that it can be retained, the volume of water that cannot be drained away by gravity, water which is retained in the soil, that is what we call it as specific retention. Retention, retained. So the volume of water retained by total volume expressed in terms of percentage is what we call it as specific retention. Water coming, each total thing is holding capacity is porosity. Out of that, some water is drained, that is specific yield. Some water is retained actually. So that is specific retention. So naturally, the specific yield plus specific retention is equal to what finally? Porosity. So porosity is equal to, what is the relation? Porosity is equal to specific yield plus specific retention. Remember that specific yield is always less than porosity. Please remember. Just for your understanding sake, we are giving here for clay, porosity is so much actually. But you see specific yield, how much it yields? Very less actually. So whereas sand, it can hold up to 40%, but it can drain off also 30%. Whereas sand and gravel, up to 35% it can hold, up to 25% it can drain off. Sandstone, 5 to 30% it can hold, 5 to 15% it can. Shale, if you take it, up to 10%, out of which 5% can be. Limestone, up to 20% it can take, but up to 5% it can drain off. But if you see clay, basically it can take actually up to 50%. So porosity of clay is very high, whereas specific yield of clay is very, very less. Please understand. Whereas sand, in the case of sand, if you take it, porosity is high definitely, whereas the specific yield is also reasonably good actually. So this is only for your understanding sake. Clay, porosity is very high, but specific yield is very less. Then what are the aquifer constants? Actually, there are aquifer constants. Some 3 constants are there. Majorly, we call them 3 constants. What are those 3 constants? One is coefficient of permeability K. Transmissibility or transmissivity is what we call it as T. And third one is storage coefficient. This is the third actually, which is also called as storativity. So these are the aquifer constants. Some people use coefficient of permeability and hydraulic conductivity almost synonymous to each other, but there is a difference between these two actually. Hydraulic conductivity and coefficient of permeability, the difference is there, but some textbooks they use it almost both are same as far as the groundwater is concerned, but we use coefficient of permeability. That is the right word which you need to use it actually. What is the permeability? Permeability means it is the property of the material. Permeability is the property of material. Material indicating its ability to transmit. What is the ability to hold? Ability to hold is porosity. Ability to transmit is what we call it as permeability. Permeability means it should be able to relieve, it should be able to drain, it should be able to yield, it should be able to transmit. That is what we call it as permeability. So it is the property of the medium indicating its ability to transmit the water is what we call it as coefficient of permeability. And what the coefficient of permeability is nothing but it indicates the velocity of flow. Coefficient of permeability is the velocity of flow which will occur through the full cross-sectional area of the soil under a unit hydraulic gradient, right? Remember, coefficient of permeability is defined as the velocity of flow which will occur through the full cross-sectional area of the soil actually or aquifer under a unit hydraulic gradient. So remember that actually. So that's why it is what finally coefficient of permeability is the velocity of flow. So what is the unit of velocity of flow? Centimeter per second or meter per second. So what is the coefficient of permeability unit also? Coefficient of permeability is expressed in terms of the velocity units meters per second or centimeters per second. For example, you take clean gravel. It is 1 actually. What do you mean by 1 actually? All the entire water actually it can transmit. Suppose if you take clean sand, it may vary 0.01 to 1 actually. Clay, if you take it, its transmission is almost negligible, 0.501. So what 0.501 represents actually? Porosity is high for clay, whereas permeability for clay is almost negligible. It cannot transmit. It doesn't transmit. That is what it represents actually. So the transmission power, the transmitting power of a soil is what we call it as permeability actually. So what is transmissivity? Rate at which the water is transmitted through the full saturated thickness of the aquifer. So naturally coefficient of permeability we use it in the case of unconfined aquifers, whereas transmissivity we use in the case of a confined aquifer. But these two can be related actually. What is the transmissivity is equal to? It is nothing but coefficient of permeability into aquifer thickness. So there are two definitions. One is coefficient of permeability, transmissivity. Coefficient of permeability is velocity actually. It is the velocity of flow which will occur through the full cross-sectional area of the soil, that is aquifer, under a unit hydraulic gradient, right? Generally, it is represented in the velocity units, that is centimeters per second or meters per. For clean gravel, it will be 1, whereas for clay, it will be 0.501, very low. Whereas what is transmissivity? Generally, transmissivity we use it for confined aquifers. How to calculate that transmissivity? It is nothing but coefficient of permeability into the thickness of the aquifer. What is the unit of that actually? So K unit is meters per second into meters. So T is equal to meters per second into meters. So naturally it is meters square per second. Please note that the transmissivity unit is meters square per second. The last one is storativity or storage coefficient. It is water yielding capacity of a confined aquifer which is expressed in terms of storage coefficient. It is the water yielding capacity of a confined aquifer which is expressed in terms of storage coefficient. That means the volume of water that aquifer releases or takes into storage per unit surface area of the aquifer under unit change in hydraulic head. Under unit change in hydraulic head, under unit surface area of the soil mass aquifer, on which the volume of water that can enter into it or that can drain from it. So this is what we call it as the storage coefficient. What is the range of value for the storage coefficient? It varies from 0.405 to 0.205. This is the variation. So 5 into 10 to the power of minus 3 to 10 to the power of minus 5. This is the 10 to the power of minus 3 to 10 to the power of minus 5. This is how it varies actually. How to determine the storage coefficient values? By pumping test we will determine the storage coefficient value. The storage coefficient for an unconfined aquifer, because for confined aquifer we have defined, for an unconfined aquifer is nothing but it's a specific yield actually. The specific yield value may be between 0.1 to 0.3. This completes to me. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.